Okay, people, we today are going to be looking at another special kind of polynomial, a trinomial. Well, it's actually not a trinomial. Uh, that if you can recognize it is super easy to factor. So this is going to make it really easy for you. And the nice thing is, it's even easier to recognize than the perfect squares. And these are not perfect squares. Are you ready for it? Can you tell by the picture what it is? They're difference of squares. See, because I'm taking two squares and I'm subtracting them. And we subtract two things is called a difference. So the difference is, yeah. Okay, anyways, back to work. Okay, so we saw in previous lessons that if I take this x plus 3 and I square it, so multiply it by itself, then the first and last terms are perfect squares, and the term in the middle is 2 times the square roots multiplied together. In other words, 2 times 1 times 3, which is 6. Okay, and that was pretty simple. But what if I take one of those binomials and change the sign on 1? So now it says x plus 3 times x minus 3. Well, if we do the distributive principle, so multiply x by x, I get x squared, and then x by negative 3, I get negative 3x, and then 3 times x is positive 3x, and 3 times negative 3 is negative 9. Then when you go ahead and collect the like terms in the middle there, they disappear, just like magic. Leaving behind, it's not really magic, just so you know, leaving behind x squared minus 9. And they do that because you had negative 3x plus 3x, and so when we add like terms together, we just add the coefficients. So negative 3 plus 3 is 0, 0 times x is 0, so I'm just left with x squared minus 9. And what you notice, or what you should be noticing, is that the square, or x squared, and negative 9 are both perfect squares. So this is just going to be x, this is just going to be 3. And lo and behold, those numbers are there. And it makes a heart because we love this. Yay! Okay, so this should work for any difference of squares. That is, you take two identical brackets, like x plus 4 and x plus 4, but instead write one of them as x minus 4, just to change it up a little bit. And x plus 4 times x minus 4 should result in a difference of squares. The same thing is true for the 2x minus 7 times the 2x plus 7. When you work it all out, your middle terms should cancel out to 0, and you should be left with two perfect squares with the subtraction sign between them. Why don't you go ahead and make sure that happens? Do it right now. I'm going to give you 3 seconds before I show you the answer. All right, that was a fast 3 seconds, wasn't it? Here we go. X times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. I see where this is going. And then 4 times negative 4 is negative 16. Negative 4x plus 4x is 0, so this just remains as x squared minus 16, a difference of squares. Likewise for the other one, 2x times 2x is 4x squared, a perfect square, and 2x times 7 is positive 14x. Negative 7 times 2x minus 14x, and negative 7 times 7, is negative 49, leaving behind 4x squared minus 49. Again, a difference of squares. Okay, so there we go. That works. Let's skip to the really easy part now, because believe it or not, that was the hard part. The easy part this time is actually factoring a difference of squares, which is what DoS stands for. Whoop! Anyways, so here we go. Here's a difference of squares. That was a weird sound. I don't know. It just kind of came out. I'm trying to sound really cool, but I just don't think I'm doing a very good job. Anyways, here we go. Here's a difference of squares. Okay, and I know it's a difference of squares because I can see that 16 is a perfect square, y squared is a perfect square, same with 81x squared. I can see what the square roots are in my head already. And so I know this is a difference of squares because they're both perfect squares and there's a minus sign between them. So difference of squares, piece of cake. Okay, so to factor it, using the pattern we saw previously, I know that all I need to know is what is the what is the square root, of each of those terms. In this case, it's 4y and 9x. Well, guess what? I'm going to put a plus sign there, call that my first bracket. Here's my second bracket. It's the same thing, only there's a minus sign there. Whoops, whoops. Ooh, easy. Calm down. Okay, there we go there. And it's factored. I don't even need to worry about magic numbers. All I need to have to do is be able to take the square root of perfect squares. So easy. Okay, so here's an example that you can try. X to the power of 4 minus 16. It's a perfect, sorry, it's a difference of squares because they're both perfect squares. So I'd like you to factor it. And do it now. Okay, so we see that each of these has a perfect square. That is the square root of x to the power of 4 is x to the power of 2. That's easy. The square root of 16 is 4. I'm going to set up two brackets with x squared and 4 in each of the brackets. In one, I put a plus sign. In one, I put a minus sign. And you go, yay, I'm done. And if you patted yourself on the back, stop it because you're not done yet. Guess what, people? Look closer. One of these factors is also a perfect square. If you can see me right now, I'm doing that thing like where my brain just like totally explodes, right? So anyways, this one here is also a difference of squares. I can factor that into x minus 2 times x plus 2. So if I factor this thing out completely, this is what it looks like. Isn't that fun and exciting? Okay, peeps, I'm going to give you one more, and this is your homework, and then you're done. There you go. Oh, but wait 1 second. Bam! I said one, but I just gave you two. Suckers! Okay, so you're going to factor these both completely. They can both be factored as perfect squares, but the key word there is completely. Okay, and both of these have a bit of a trick to them. So I'll give you an extra few minutes of homework tonight. Like it might take you 5 minutes. That's in addition to the 7 minutes you just spent. That's 12 minutes of homework. Write a letter to the the member of MLA? MLA, that's the one. And complain to them because I'm totally torturing you with homework. All right, folks, slaves, enjoy the questions, and I hope you've enjoyed this video because I've had a lot of fun making it, and I can't wait to see you tomorrow. Like, I'm actually really looking forward to it. Okay, see ya.